Hello everyone, this is G. Jairaj. Today we are going to discuss the topic joint Gaussian random variable. Let us take two random variables x1 and x2 are said to be jointly Gaussian. Then the joint density function is given as f x1 x2 of x1 comma x2 equals to 1 by 2 pi sigma x1 sigma x2 root over 1 minus rho square exponential of minus 1 by 2 of 1 minus rho square of x1 minus x1 bar whole square by sigma x1 square minus 2 rho of x1 minus x1 bar of x2 minus x2 bar by sigma x1 sigma x2 plus x2 minus x2 bar whole square by sigma square x2, where the x1 and x2 are mean values, that is the expectation of x1 and expectation of x2. Variances are given by sigma x1 square and sigma x2 square, which is equals to the expectation of x1 minus x1 bar whole square and expectation of x2 minus x2 bar whole square, where rho is the correlation coefficient, which is given by expectation of x1 minus x1 bar of x2 minus x2 bar divided by sigma x1 sigma x2. Now we will get the maximum value of the density function at the mean values of it, that is x1 bar and x2 bar, which is equals to the f x1 x2 of x1 comma x2 equals to 1 by 2 pi sigma x1 sigma x2 root over 1 minus rho square, where rho is the correlation coefficient. Now we will take the n random variable case. Consider n random variables xn, where n equals to 1, 2, 3 upon n. They are said to be jointly Gaussian if their joint density function is given by f x1 x2 upon so on xn of x1 comma x2 comma upon so on xn equals to 1 by 2 pi whole power n by 2 determinant of c whole power 1 by 2 exponential of minus 1 by 2 x minus m whole transpose c inverse x minus m, where t denotes the transpose of a matrix, where xm equals to x1 minus m1 x2 minus m2 so on xn minus mn, where m1 m2 m3 mn are the mean values of the random variable. Covariance of n random variables is given by c equals to c11 c12 upon so on c1n, and similarly cn1 cn2 upon so on and cnn. For example, the joint density function for two random variables x1 and x2 can be derived by substituting n equals to 2. The covariance for n equals to 2 is x minus m equals to x1 minus m1 x2 minus m2, and cx matrix equals to c11 c12 c21 and c22. If we substitute these values in these terms, we will get the jointly Gaussian function. Now let rho equals to 0 in the above f x1 x2 of x1 comma x2, that is x1 and x2 are uncorrelated random variables. Then the above f x1 x2 of x1 comma x2 is written as 1 by 2 pi exponential of minus 1 by 2 of x1 minus m1 whole square by sigma x1 square plus x2 minus m2 whole square by sigma x2 square, which upon solving we will get the final answer as f x1 x2 of x1 comma x2 equals to 1 by root over 2 by sigma x1 square e power minus x1 minus m1 whole square by 2 sigma x1 square by 1 by root over 2 by sigma x2 square e power minus x2 minus m2 whole square by 2 sigma x2 square, resulting in the final equation as f x1 x2 of x1 comma x2 equals to f x1 of x1 f x2 of x2. This is the required one. Thank you.